Alrighty then, this is Calculus 2, 2.1, rates of change and the derivative. Now, as we're going over this, a lot of it's going to be pretty quick because you guys already know this, except for the derivative of tangent. Okay, find the equations of the tangent line and the normal line to the graph of a function. Find the rate of change of a function. Find the average velocity and instantaneous velocity. Find the derivative of a function at a number. So, the tangent, m. We know m stands for what? Slope. So, it is the slope of the tangent is equal to the limit as x goes to c, okay, of fx minus f of c. Yeah, so it's basically my 2 points there. So I'm basically getting the slope of the tangent is the same thing as saying f prime of c. So finding the derivative at c. That's what that means. Borderline is off. Okay. If m tan exists, the equation of tangent line to the graph of f at the point P, okay, that's going to be c comma f of c, because point P is where my x value is, and f of c is where I plug it in there to find that. Okay, so we actually have this right here, which is point slope formula. It's the point slope formula. Okay, right here is where we have my slope. We know that this f prime is going to be the slope. Okay, x minus, and this is normally would be like x minus x1, and this would be y minus y1. So that's basically, it's the exact same thing, it's just another way of writing it. Now, the one that's probably going to get you guys is this next one is line perpendicular to the tangent. So we know tangent is touching the line at one point, right? That's the slope of the line. Okay, slope. Now, if two things have perpendicular slopes, I know that their slopes are what? Opposite and reciprocal. Opposite and reciprocal. That's where we get the perpendicular line from. To the tangent at point P of the graph, okay, it's referred to as the normal line. They're not going to say it's perpendicular to the tangent. You need to know that it is perpendicular to the tangent, because you will know that. You will know that. It's really important. You will know that. Okay? Now, it's going to be called the normal equation of the normal line. It's the same thing. The only thing they changed is right here. So, it's the slope. It's just taking the reciprocal of the slope and the opposite. So, it's opposite reciprocal of the slope. Okay, provided f prime of c exists and is not equal to 0, if f prime of c is equal to 0, the tangent line is horizontal, the normal line is vertical, and the equation of the normal line would be x equals c. So, okay, x equals c, that's going to be a line going straight up and down. Okay. Find the slope of the tangent line of the graph here. Okay, now, I'm going to kind of cheat on this, because we've already done all that limit stuff already, right?
Yeah.
Okay, so we've already done derivatives one time already, right?
Yeah.
Okay, so there's certain things that you should be able to do by now. Okay, so what's the derivative? What is f prime of that one?
2x.
F prime of x is equal to 2x, right? So, at the point where c is negative 2, what's the slope going to be?
Negative 4.
F prime of negative 2 is negative 4. Oh, this is killing me. Okay, I was just informed that I did make a mistake. I accidentally put the wrong number here. So this should be f prime of negative 2 is equal to that. There we go. All right, so there we go. When the result of A, find an equation of a tangent line when this is here. So we know that the slope is this, right?
Yeah.
Okay, if the slope is that, let's plug it into the formula. So my y value, okay, my y value is going to be what? It would be y minus a y value. What is that y value going to be? It's not negative 4. It's positive 4.
Oh, yeah.
Because we're going to have, okay, my coordinate is going to be c comma f of c, right? So I have to plug it in to find the y value. So the x value would be negative 2, but the y value would be plugged in here, so we get a positive 4. Minus, oh, I'm sorry, equals my slope. We said my slope is what? Negative 4, parentheses, x minus negative 2. There we go. So take it from there, I'm going to get y minus 4 equals negative 4x, and that's going to be minus 8 plus 4 plus 4, y equals negative 4x minus 4, and that is the equation. What? Did I mess up?
It's a lot of 4. Yeah.
Oh. What are you laughing for?
Negative 4x
All right.
Yeah, I don't know why you say it over and over.
Okay, anyway, but still. All right, so we should be okay here, right? Okay, find an equation of a normal line to the graph of f at that point, okay? So, normal line at this point, okay? So, it's going to be y minus 4 equals, now, what's going to be my new slope now? Positive 1/4, right?
Yeah.
It's opposite reciprocal, x minus negative 2. So y minus 4 equals 1/4 x, and that's plus 1/2. Y equals 1/4 x, and so if I'm adding 4, that's 8 over 2, that's plus 9 over 2. Yes?
Yeah.
There's the equation of a line that's perpendicular to the tangent at the same point. D, graph F. The tangent line to F at those points, and the normal line to F at those points on the same set of axes. So, you guys are going to graph them. So, handy dandy calculator, right? So my first one was it negative 4x? Negative 4x minus 4?
Yeah.
Okay, and then my other one would be 1/4, right? 1 over 4 x plus 9 halves.
I mean 9 halves. Oops.
9 halves. There we go. All right, so your graph should be messed up right now, so let's go fix that. Window zoom, and let's do standard. There we go. There we go, we're at there. Okay, isn't this the original right here?
Like the original.
Okay, these are the tangent, this is normal. Is that what it said? It said
X squared. Graph F.
the tangent line to F. Oh yeah, you're right. And then the first one, x squared. You're right. Sorry. So I need to throw in an x squared here also. So x square. There we go. So there we go. So right here, it's this line is graph and touching right there at that one point. Okay, it's touching right there at that one point, so that is the slope of the graph at that point, and then this is perpendicular to that graph also. Make sense?
Yeah.
Questions, concerns, complaints? Okay, good. All right. Okay, definition, instantaneous rate of change. Okay, instantaneous rate of change of f at c is the limit as x approaches c of the average rate of change. Symbolically, the instantaneous rate of change of f at c is here. The limit as x approaches c, whichever number that is, provided the limit exists. Okay, find the rate of change of this function at here, and then at any real number. So we're going to do this since we already know this. So basically, I'm going to have derivative there. So f prime of x is going to be 2x minus 5. There we go. So this actually takes care of part B. And then part A would be f prime of 2. Now, we plug that into the derivative, right? Plug it into the derivative, so we're going to get 4 minus 5 is the -1. There he is right there. Está muy fácil? Sí. All right. Finding the rate of change in biology experiment. Metabolic experiment, the mass of M, glucose, decreasing according to the function. So we have a function right here according to what? In terms of what?
Mass.
Nope, try again. Time. Okay? We're taking the derivative in terms of time. Okay, when we get towards related rates later on, where we're actually doing the optimization and stuff like that, it's very important that we identify that everything is in terms of time. So M is measured in grams, G, T is time in hours, H. Find the reaction rate, M prime of T, at here. So first thing, let's take the derivative. Okay, my derivative. So M prime of T will be what?
-0.06 t. Yeah. 0.
Like that?
Yeah.
Okay.
What?
And then it said, so M prime of 1 is going to be -0.06 times 1. So M prime of 1 is -0.06. So at that point, we know it is decreasing at that rate. Biologically, glucose is decreasing at this rate. So if I were to say this on the AP exam, I would have to state that it's decreasing at this right here. Okay? Decreasing at this number. Okay? So you don't say negative though.
Decreasing.
The negative is the decreasing part, right?
That's
It's like saying a double negative, right? Yeah, we don't need no education. Yes, you do. You just use the double negative. All right. So we would just say it's decreasing at this number. Okay? Make sense?
yes.
Okay, good. All right. Average velocity. Velocity. Okay, if a rock falls, blah, blah, blah. Okay, wait, hold on. Where are we at? Mike O'Callahan, Pat Tillman Memorial Bridge, spanning the Colorado River.
That's a mouthful.
Yeah, but yeah, anyway. All right. Open October 16, 2010. Having a span of 1,900 feet. It's the largest arch bridge in the Western Hemisphere, and its roadway is 890 feet above the Colorado River. Wow, okay. If a rock falls from the roadway, the function S, okay, that gives me my position, right? S is the position function, is equal to f of t, which is the function in terms of time, which is equal to 16t squared, gives the distance s in feet, and that the rock falls after t seconds, where from 0 less than equal to t, so it's between those times. Okay, here, 7.458 seconds is the approximate time it takes the rock to fall 890 feet into the river. Average velocity of the rock during this fall is Okay, so average. There we go.
Is that rate of change?
Okay, yes, just rate of change. Delta x over delta time. Or delta s over delta t, so. Alright, so I plug them in, right? So it's basically finding the slope of my, so I start and end. Right?
Right, yeah.
Okay, so I plug it in, start and end. So starting at 0, okay, and then ending at that. Okay, so it comes up to 119.335 feet per second. That is going really, really fast. Okay, if you were to jump off that, by the time you hit the water, water has a special property where the faster you go, the harder it is. Yes, you would be hitting concrete basically.
Bounce on water.
Yes, you would bounce on water. Okay, so definition: instantaneous velocity S-f of t is a function that gives distance s. Object travels in time, so distance s, time t. Instantaneous velocity v is the object at time t naught, which is defined as the limit as the average velocity, delta s over delta t, as delta t approaches the 0. So velocity is equal to this. So it's the same thing that we just did, right?
Yeah.
Yeah, it's the same thing that we did. Where, do you know what t sub naught, this right here? That's my initial, right? That's my initial there. Alright, so provided the limit exists. Okay, find the velocity v of the falling rock in the previous example at 1 second. So, find it. So what was the function?
16 t squared. 16 t squared.
I might have made a mistake on these PowerPoints because t squared is what type of shape? Which way does it go? So,
Yeah, that's when
I was
you
like-
grabbed it, he's like, oh.
yeah.
That's why there's a bound on it, though. 7.4
Yeah, but that's when it's supposed to be hitting the water,
We go
not
up-
hitting the airplane flying over.
It's just the distance from
Did
the
you drop it off
bridge.
this bridge in Colorado?
It would be positive if it was just
Yeah.
the distance from the bridge.
Yeah.
Oh yeah. Okay, yeah. If it's the distance, you're right. So distance from the bridge. All right. So now first, I'm gonna get f prime of t is 32t. So f prime of 1 is 32. Okay. Now 7.4. So f prime of 7.4 is going to give me, go ahead, you can do it.
Let me do it this way. 236.8.
And what are my units?
Feet.
Okay, is this velocity? It is velocity, so what would my units be?
Feet.
Okay, so feet,
Per second?
yes, per second. Now, same thing for this one right here. So, velocity. Velocity is always a distance over time, so make sure you label it correctly. Alright, I think that is it for you people today. Yeah, that's it for today. Alright. Okay. Do your homework. Don't forget to like, subscribe.